Hello everyone, welcome to my channel. This video is in continuation to my previous video. In this video, we will discuss section C of my 2019 paper of Mathematics-1. So let's begin. You can have a look at the section C of the question paper. It consists 4 questions and you have to do at least 2 questions from this section. So let's start with question number 15. So question number 15, show that the matrix 2 0 minus 1 5 1 0 0 1 3 satisfies the equation a cube minus 3a square plus 11a minus I is equal to 0. One way of doing this question is that you find a square, you find a cube and put here in this equation. Okay. The other way is by Cayley-Hamilton theorem. So I will do Cayley-Hamilton method here. So I will find out the characteristic equation. By Cayley-Hamilton theorem, we know that every matrix satisfies its characteristic equation. So I will find out the characteristic equation here for this matrix. I will find out the characteristic equation. So let's find out the characteristic equation. So a minus lambda determinant equal to 0. So 2 minus lambda 0 minus 1, 5 1 minus lambda 0, 0 1 3 minus lambda. We'll put this determinant equal to 0. So let's solve this determinant by expanding through the by expanding it through a particular row. Okay, so I'm expanding it through the first row. So this is 2 minus 5. So sorry, 2 minus lambda. So when you expand through the first row, write down 2 minus lambda, remove this and multiply with the determinant of this matrix, which is 1 minus lambda, 3 minus lambda, minus 0. Then this is 0. Then we have minus 1. Multiply by the determinant of this matrix. So determinant of this matrix is 5. Okay, so we get this. Now let's just open up these brackets. So this is equal to 2 minus lambda. Inside, if you open up this, it will become 3 minus lambda minus 3 lambda. Minus lambda minus 3 lambda will become minus 4 lambda plus lambda square minus 5 equal to 0. Now let's expand it more. So it is 6 minus 8 lambda plus 2 lambda square minus 3 lambda plus 4 lambda square minus lambda cube minus 5 equal to 0. So just simplify it. It will become minus lambda cube plus 6 lambda square. Coefficient of lambda square 2 lambda square 4 lambda square will give me 6 lambda square. Then coefficient of lambda minus 8 minus 3 will give me minus 11 lambda, and the constant term 6 minus 5 will give me 1 equal to 0. Now change the sign. Okay, change the sign here. Now it is lambda cube minus 6 lambda square plus 11 lambda minus 1 equal to 0. So matrix will satisfy this equation. This is the characteristic equation, and the given matrix will satisfy this equation. So a cube minus 6a square plus 11a minus I is equal to 0, and hence we have proved it. Now next question. 16th, let T from R3 to R2 be the linear transformation defined by T of x, y, z equal to x plus y, x minus z. Then find the matrix representation of T with respect to ordered bases x in R3 and y in R2. Okay, so some bases are given for R3 and R2. We have to find out the we have to find out the metric representation of T. So what we will do, we will find out the image of these bases first under T. Okay, let's find out the image of these bases under T. So these are the bases. Let's find out T of 100, T of 110 and T of 011. Okay, so what is T of 10101? You have to put x equal to 1 and z equal to 1 in here in the transformation. So put x equal to 1 and z equal to 1. So we get 1 plus 0 to be 1. Then 1 minus 1 to be 0. So we get 1 0. Then T of 110, put x equal to 1 and y equal to 1. So we get 1 plus 1, 2, and 1 minus 0 to be 1. Then put 0 1 1. So put x equal to 0, y equal to 1 and z also equal to 1. So x equal to 0, y equal to 1. So 0 plus 1 will give me 1, and 0 minus 1 will give me minus 1. Now what we have to do, we have to express these images in terms of 1 0 0 1, which is the basis of R2. We have to express these the images in terms of 1 0 0 1. So now you can see 1 0 1 0 can be expressed as 1 times 1 0 plus 0 times 0 1. 2 1 can be expressed as 2 times 1 0 plus 1 times 0 1, and 1 minus 1 can be expressed as 1 times 1 0 plus minus 1 times 0 1. Okay, so we'll write these coefficients now in form of matrix. Just write these coefficients in the form of matrix and then take the transpose of that matrix, and that will give us the matrix representation of this linear transformation. So the matrix associated with linear map T relative to given basis is transpose of the coefficient matrix. So it is 1 to 1, 0, 1, minus 1. So this completes 16th question. The next question, 17th question, A part. Is the matrix P 4 to 1, 6, 3, 4, 2, 1, 0 orthogonal? So for orthogonal matrix, what you have to check, P into P transpose, that should be equal to identity matrix, and P transpose into P, that should also be equal to identity matrix. So let's just find out P into P transpose. Write down the matrix P and take its transpose. And in transpose, row get changed to columns and column get changed to rows. So here you can see 4 to 1 is the first row. 4 to 1 becomes the first column here. 634 is the second row. 634 become the second column here, and 210 is the first row. 210 is the third row. 210 becomes the third column. So now let's just multiply them. Multiply first row with the first column here, then multiply first row with the second column, multiply first row with the third column, like that. Okay, everyone, I think everyone who is doing B.Tech right now, everyone know how to multiply two matrices, right? So I don't need to explain the matrix multiplication. Okay, so you can see, you can multiply them and you'll get this, and this will come out to be 21 34 10 34 61 15 10 15 5, which is not equal to identity matrix. It should come out to be equal to identity matrix if the given matrix is orthogonal, but it's not coming out to be identity matrix, so given matrix is not orthogonal. Now 17th question, B part. Express A equal to 1, 2, 5, 4, 5, 6 as a sum of a symmetric and a skew symmetric matrix. So there are 5 steps in this question. You have to follow those 5 steps. First step is find out a matrix B, which is A plus A transpose divided by 2. So find out the matrix B, write down A, write down its transpose, add them and divide by 2. Do the element wise addition and then divide by 2. So it is equal to 1 plus 1 2, 2 plus 4 6, 3 plus 7 10, 4 plus 2 6, 5 plus 5 10, 6 minus 8 minus 2, 7 plus 3 10, minus 8 plus 6 minus 2, and 9 plus 9 18. Now divide by 2. When you divide by 2, you will get 1 3 5, 3 5 minus 1, and 5 minus 1 9. This is the first step. Now second step is to find out B transpose and show that this is equal to B. Now find out, we have got B, find out B transpose. You will see that it is coming out to be equal to B. This shows that B is a symmetric matrix. This shows that B is a symmetric matrix. Now third step is to find out C. C is A minus A transpose divided by 2. So write down the matrix A minus, write down A transpose. Okay, so just calculate it and divided by 2, you will get the matrix C. Now fourth step is to find out C transpose. Find out C transpose. We have got C. Find out C transpose. It will come out to be equal to minus of C. Okay, you can see all the elements in C transpose are having opposite sign as that of C. If it is -1 here, here we have 1. If it is -2 here, here we have 2. Here we have -1, here we have 1. Okay, so all the elements are having opposite sign. So C transpose is equal to -C. So C is a skew symmetric matrix. Now the last step, just add B and C. When you add B and C, the matrix which will come after addition, that will be equal to A. Okay, that will be equal to A. So hence we have expressed A as symmetric, as a sum of symmetric and skew symmetric matrix. You can see this is A, right? We have expressed A as sum of B and C, where B is symmetric and C is skew symmetric. This complete this question. Now next question. Reduce the matrix A -1 2 -2 1 2 1 -1 0 to diagonal form. This is quite lengthy question. Okay. So if you know the answers of 16th 15 16 17th question, then don't do this question in exam, because it will take time. Okay, it will take time. If you do not know how to do 15 16 17th question, then you can do this question. Okay, but you have to manage your time if you have to do this question. It's a quite lengthy question. So to make it of diagonal form, firstly you have to find out eigenvalues, then you have to find out eigenvectors, then you have to find out P matrix. P matrix consists of eigenvectors as its columns, right? Then you have to find out P inverse. For P inverse, you need to find out the determinant of P, adjoint of P. Then after finding P inverse, you have to find out P inverse AP. P inverse AP will come out to be equal to diagonal matrix, and this will diagonalize this matrix. Okay, so it's a lengthy question. It's a lengthy question. So I will provide you a solution to this question. Okay, so let's start. So firstly, find out the eigenvalues by equating the determinant of A minus lambda I equal to 0. So find out A minus lambda I and put that determinant equal to 0. Okay, so we have got this. A minus lambda I, will put it equal to 0. Determinant of A minus lambda I equal to 0. Let's expand the determinant using the first row. So -1 minus lambda multiply by 2 minus lambda minus of -1, which becomes +1. Then minus 2 for this, remove for -2 for 2, remove this and remove this, so we get minus lambda minus of -1, so which becomes +1. Then minus 2 for -2, remove this and write the determinant of this one. So it is -1, it is -1 minus of -1, which will become +1, 2 minus lambda, which is equal to 1 minus lambda. So I have directly written 1 minus lambda here. So this is 1 minus lambda. Here also we have 1 minus lambda. So together it will become -4 times 1 minus lambda. Okay, so -4 1 minus lambda, and if you'll open up this, it will become -2 plus lambda square. So I have just multiply minus lambda with this, so lambda square minus 2 lambda plus 1. Okay, further let's just open up it a bit more, or okay, what we can do, this factor can be written as lambda minus 1 whole square. You can see lambda minus whole square is equal to lambda square plus 1 minus 2 lambda, right? So it can be written like this. So 1 minus lambda minus 1 square plus 4 times lambda minus 1. So take out lambda minus 1 outside. Lambda minus 1 can be taken outside common. So inside will be left with -1 minus lambda minus 1 plus 4. Okay. Now just solve it. It will become minus lambda square plus 1 plus 4. So we get minus lambda square plus 5 equal to 0. So we get 3 eigenvalues from here. one is lambda equal to 1, other two is root 5 and minus root 5. So these are the three eigenvalues of A. Okay, we'll find out the eigenvectors corresponding to these eigenvalues. So let's find the eigenvector corresponding to lambda equal to 1 first. So A minus lambda, A minus 1 times I into x1 will be equal to 0. So let's solve it. Write down A minus 1 times identity matrix xyz equal to 0. So let's solve it. So we get minus 2, 2 minus 2, 1, 1, 1, minus 1, minus 1, minus 1. So we will, you can see the rank of this matrix is 1. Sorry, not 1. The rank of this matrix is 2. If you can't see here clearly, then what you can do, you can reduce it to echelon form and then you can find out its rank. So you can reduce it to echelon form. Firstly, reduce the third row by applying the transformation R3 goes to R3 plus R2. Okay, so apply this transformation first. Then what you can do, you can divide the first row by 1, okay, to make 1 everywhere, okay, to make your calculation more easier. Okay, then you can add the second row with the first row. In second row you can add the first row. Okay, so apply the transformation. R3 goes to, I'm sorry here, apply the transformation. R2 goes to R2 plus R1. Okay, apply this transformation. So you get minus 1, 1 minus 1, 0, 2, 0. Okay, now just make the equations here. So minus x plus y plus z minus z equal to 0 and 2y equal to 0. From here the value of y comes out to be 0. Okay, so put the value of y 0 here. So we get minus minus x minus z equal to 0, and from here the value of x comes out to be minus z. So we can let z to be 1. So if z is 1, x will be equal to minus 1 and y is 0. Here rank of this matrix is 2, right? So we will have n minus r linearly independent solution, right? So n is 3 minus 2, 3 minus 2, 1. So we will have one linearly independent solution. Others will depend on this, right? So we are getting y to be 0, x to be minus 1 and z to be 1. So this is the one linearly independent eigenvector of A for lambda equal to 1. Now we will find out the eigenvector for lambda equal to root 5. So for lambda equal to root 5, same thing you have to do. Okay. A minus root 5 times I x2 equal to 0. Okay, make the equation, make the system of linear equation here. Okay, now again reduce it to echelon form. What you can do, interchange the first row and the second row. Okay, interchange first row and the second row. So it is 1, 2 minus root 5, 1, minus 1 minus root 5, 2 minus 2. Okay, now make this 0, make this 0 and make this 0. Okay, so we can apply the transformation. R3 goes to R3 plus R1 and R2 goes to R2 plus 1 plus root 5 times R1. So apply this transformation. It will make 0 here and 0 here. Okay, and here you will get minus 1 plus root 5. Here you will get minus 1 plus root 5. Here you will get 1 minus root 5 and here you will get 1 minus root 5. You can solve it and you can check. Okay, now make the, now here you can see the third row can be reduced to 0 by applying the transformation. R3 goes to R3 plus R2. So third row will be reduced to 0. Okay, so here again you will get one linearly independent eigenvector because rank is 2. So 3 minus 2 is 1. Okay, so now make the equation from here. From the second equation will be y plus z equal to 0, because if you divide this by minus 1 plus root 5, if you divide the second row by minus 1 plus root 5, you will get 1 here, 1 here, right? So the second equation which you will get is y plus z equal to 0. Now from second equation, y is equal to minus z. So let let's take the value of z equal to 1. So if z is 1, y is equal to minus 1. Okay, so I'm taking z to be 1, then y from here will be minus 1. And if we put the value of y and z in first equation, you can see if I put y to be minus 1 here, I will get here minus 2 plus root 5. And if I put the value of z to be 1, I'll get 1 here. Okay, this is equal to 0. This is equal to 0. So minus 2 plus 1 will give me minus 1, right? So it is minus 1 plus root 5 equal to 0. Minus 1 plus root 5 equal to 0. So from here, we get the value of x to be 1 minus root 5. You can take this the other side. So you get the value of x to be 1 minus root 5. So we get eigenvector corresponding to lambda equal to root 5 to be 1 minus root 5 minus 1. Y is minus 1 and z is 1. Then for lambda equal to minus root 5, again you can do the same things. Okay, for lambda equal to minus root 5, make this equation, solve it, reduce it to echelon form. Okay, interchange r1 and r2, bring 1 here, make this 0 and make this 0. Okay, apply the transformations. R3 goes to R3 plus R1 and R2 goes to R2 plus 1 minus root 5 times r1. Okay, it will make 0 here. In the second row, first element will become 0, and in third row also first element will become 0, and this you can check. You will get these things. You can check it yourself. Then apply the transformation. R3 goes to R3 plus R2. It will reduce the third row. Okay, now you can divide the second row by minus 1 minus root 5. Otherwise, what you can do, you can make the equation and then divide that equation with minus 1 minus root 5. So you will get x plus 2 plus root 5 y plus z equal to 0. Y plus z equal to 0. From here again we get y equal to minus z. So you can let the value of z to be 1. Then y will be equal to minus 1. Put this value here in this equation, the value of y and z. Put y equal to minus 1 and z equal to 1 here. You will get x equal to 1 minus root 5. So we get one eigenvector corresponding to lambda equal to minus root 5 here. Okay, this is the eigenvector. Now what we will do next, we will find out P. Now what is P? P consists of the eigenvectors as column. So we have written x1, the first eigenvector, x1, x2, x3 as columns of P. This is x1, this is x2, this is x3. We have written the columns of P as the eigenvectors. Okay, we will find out determinant of P. Determinant of P will come out to be 2 root 5. Then you have to find out the adjoint of P. Okay, I hope you can find out adjoint yourself. Okay, adjoint is the transpose of the cofactor matrix. Okay, you have to find cofactor of each element. Okay, make a matrix of that and then take the transpose. So adjoint will come out to be this. Okay, now P inverse will be equal to 1 upon P, 1 upon determinant of P into adjoint P. Okay, so just find out P inverse. So it will be 1 upon 2 root 5 into adjoint of P. Once you got P inverse, find out P inverse AP. P inverse, write down P inverse, write down A, write down the matrix P. Multiply these two matrices first. Okay, you will get this matrix and then multiply these two. You will get a diagonal matrix. And observe here, the diagonal elements are nothing but the eigenvalues only. Okay, these were the eigenvalues which we calculated, right? So you will get eigenvalues on the diagonal only. Okay, so it's a very beautiful question, very nice question. You can see the beauty of this question. In the end, we are getting eigenvalues only. Okay, so in this way, we have reduced the matrix to diagonal form. And this completes our My 2019 paper. I hope you like this video. Please like, share and subscribe my channel. Don't forget to hit on the bell icon that will notify you for the latest update, for the latest videos. Thank you so much. Take care. Have a good day. Bye bye.